So we're going to construct the Maclaurin series, and we're just going to work out the coefficients for our first couple terms of this Maclaurin series. So Maclaurin series, meaning that this is a simple form of the Taylor series where C is equal to 0. Okay, so let's start building this polynomial. So we're going to call it P of x, and for A0, we're just going to take E of cosine of the center, which is going to be 0. Okay, so when we work that out, cosine of 0 is going to be 1, so we end up with the first term equal to 1. Okay, so that's A0. Okay, so then we move on to the next term, A1. So this will involve the first derivative of this. So this is going to be e to the cosine of c, and then we need to apply the chain rule. So negative sine of c. Okay, so we've differentiated the first term. We probably should divide by 1 factorial just so that we remember that it's there. And then we have our power series part, which is x. So then evaluating this part here, cosine of C0 is 1, e to the 1, sine 0 is 0, so we end up with this term being 0. Okay, so that kind of just disappears. So the next term we call A2. Okay, we're going to use the product rule here. So we're going to end up with e to the cosine of c times negative sine c times, so this is the first part of the product, times negative sine c, okay, plus e to the cos c, and then differentiating negative sine c differentiates to negative cosine of c. Okay, so that's the second part of the product. So maybe I'll group that in this way so you can see what it is. So that's the product rule here, and got an extra line in there. There it is. The product rule is going to be here, and there's that other part of the product rule. So we've differentiated that, we found the second derivative, okay, and then we're going to divide all that by 2 factorial, and then we're going to end up with the power series part, which is x squared. So I could do one more term, but it looks like it's going to be pretty messy if I do that. So I think we'll just leave it at that and work out that coefficient. And so this is going to work out to be, well, these are zeros, so we're just going to end up with 0. And then we're going to end up with cosine e to the cosine of 1, cosine of 0, which is 1. So we're going to end up with e to the 1. Cosine of 0 is 1, so we get negative 1. So the coefficient works out to be negative e over 2 factorial, and then that's going to be x squared. Okay, so there is the first 3 terms of our Maclaurin series for this. We could do one more, but again, it's probably going to involve, it looks like it's probably going to be an even function, so every second term is going to disappear. And so when we do the next derivative, it's going to be quite messy looking, but we can do it. And that's the beauty of this, in that if we want to actually, this is where the power of this comes in, because if we want to actually compute cos x, okay, if we want to compute values for cos x, for different values of x, unless they're nice angles, it's really hard to do. We can't do this exactly, in fact. We have to rely on measurement, and we don't want to be able to have to rely on measurement. Now we have a calculation that will calculate the cos x part of this, which means then we can use this series to generate any degree of accuracy, and we don't have to rely on measurement anymore. And we can get more and more and more as accurate as we need for any kind of practical purpose. So we're going to also look at the graph of this in the next video. So we'll just see how well this fits, and we can see how the graphs match up.